All right, good morning, pre-calc people. So today we are going to start working, we're going to continue working on graphs, trigonometric graphs that are not sine and cosine. So mostly secant and cosecant. Let's see where this takes us. All right, so we go ahead and share our screen here. Okay, and have a gander at like what's going on here. And this is a good problem. Okay, cosecant of 2 pi x. And the reason why it's a good problem is this 2 pi x really confuses students a lot of times. If you're going to go into electrical engineering, this is a pretty common period that they put in here. Okay, so we're going to say y is equal to cosecant of 2 pi x. All right, so we could again do the 2 pi over b. Let's say this is 2 pi over 2 pi. So we have a period of 1, okay? Because in our world, things happen in 1 second or 2 seconds. They don't happen in 2 pi seconds, okay? I mean, they can, but, you know, as engineers, as humans, we have a hard time measuring 2 pi seconds, right? So what we're going to do here is we're going to make the period 1 second. So again, I'm just going to write down my usual points here. Okay, we have 0, we have pi over 2, we have pi, 3 pi over 2, and 2 pi. Right? And in each case, we're going to go ahead and we're going to put our 2 pi x equals 0. So x is equal to 0. So no phase shift. 2 pi x equals pi over 2. So we're going to say this is x equals pi over 4 pi. All right, 2 times 2 will be 4, and then it's pi. Pi's cancel, we get 1/4. Okay, so 2 pi x is equal to pi, so x is equal to pi over 2 pi, so this is going to be 1/2. Okay, 2 pi x equals 3 pi over 2, and x is equal to 3 pi over, again, 2 times 2 is 4 pi, so we get 3/4. And then finally, 2 pi x equals 2 pi, so x is equal to 1. All right. So let's see what they're going to ask us. Oh, they just want us to draw it. Okay, good. Okay. So if I go ahead and I sketch out my my sign here, okay, because cosecant, right, is inverse function, or an inverse reciprocal function for sine. All right, so that's all I'm going to do first is write this out. Okay, here's 1, 0. Here's 1/2, 1/4, and 3/4. Okay, so we're just putting up our points for our sine. Okay, and now we're going to sketch in some other things. So our cosecant, right, we've got asymptotes here, right, at 0, at 1/2, right, normally pi, but 1/2, and at 2 pi, okay, 1 period through. So there's our asymptotes, okay. And to draw our function, right, we're going to take this, we're going to, okay, what's the reciprocal doing? All right, so there is our cosecant function. And I urge you, practice on a piece of paper before you run through and do all of this, because your quizzes are going to look things like graph it. Okay, later on when you get to Calc 2, you're going to be doing something like taking cosecant from this point to that point and rotating it around the axis in order to get the volume that this thing looks like. So being able to do this a little bit by hand will help you figure out, like, well, what's going to happen later. Okay, so that's what we do in Calc 1, Calc 2 rather. Okay, so let's see, we need some asymptotes. So we have an asymptote here and here and here, right, at 0, 1/2, and 1. We don't have a horizontal asymptote. Okay, but at pi over, right, at 1/4, right, what's happening here at 1/4, right, we are at 1. Excuse me. All right, so 1/4 we're here, 0.75 we are down here. So let's see, we need 3 consecutive asymptotes and 2 points, 1 on each side of the second asymptote. All right, I think that does it for us. Hey, look at that, it filled it in for us. Okay, but rather than have a computer do all of the work, okay, you kind of have to have an idea of like how to sketch this thing. So even though you can look at it and say, yeah, it looks good. Okay, I have a friend, we used to go to a gymnastics gym, and she can do a cartwheel on the balance beam. I've watched that so many times. It's amazing, like, as a human being. And I know some of the people that did gymnastics in the class are like, yeah, I could do that. What's the big deal? Like, you don't understand. You're superhuman. Okay. As many times as I could watch that, all of you would pay good money to watch me attempt it, because it would be a disaster and I would hurt myself in a very, well, comedic but very permanent way. So just because you watch somebody do it doesn't mean you can do it. So I urge you to go through and do this, okay, by hand. At least a few of them, so you have an idea of like what you're going to do, because like I said, in Calc 2, they're going to expect you to make a sketch of the problem before you go on and do more. And if it's taking you a long time to do this, you don't really know how to do this part of it. Like it's like watching music people. Like if I have to read music here, and I'm doing, well, that's an E, okay, and every G, every good boy does fine, and I've got to go through and do all of this. Like, honestly, you're going to die of old age by the time you finish Twinkle Twinkle Little Star. So try to do some of this stuff so that it just comes out of your pencil. Okay, and you just learned it, so don't, not tomorrow, but you should practice it every once in a while and say, can I graph this? All right. So, all right, let's go to the next one and try something else. All right. Cosecant of, well, they're like into cosecants today. So we're going to do cosecant of pi minus 4. Okay, so let's go back to our notes here. Go back to 1. All right. So cosecant to pi minus 4. So what we're going to graph first is we're going to graph sine, right, of x minus pi over 4. So this isn't really too bad because there's no period shift, there's no amplitude, there's no horizontal. It's just a phase shift, okay? And all we're doing is we're shifting the value over by 1, or by pi over 4. Okay, so if I'm going to go ahead and do this, all right, my normal points are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So first thing I'm going to do is like, well, I got to shift it over by pi over 4. So can I do this? Can I say 0, 2 pi over 4, 4 pi over 4, 6 pi over 4, and go ahead and do it. That is going to be 8 pi over 4. Okay. And we're just going to add pi over 4 to everybody here. So it's going to be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. Okay, that's all we're doing there with that. Okay, I just added pi over 4. I added 1/4 to each of my easy values here. Okay, and then we're just going to go here. We're going to say that's pi over 4. That's going to be 9 pi over 4. Okay, here's going to be half of that, right? It's going to be 5 pi over 4. Half of that, that's going to be 3 pi over 4. And here we have 7 pi over 4. Okay, now here's, I'm going to dot in my sign. Excuse me. I'm going to dot in the sign here. So we start here. Here's 1, -1. So here, 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 and here. Okay, so we're going to dot this in. Okay, we're going to draw our asymptotes. Okay. And then we're going to sketch in our cosecant. Right? So cosecant is going to be here. And it's reciprocal of sine. That's why we dotted that in first. Okay. If I was smart, I would have put the 7 pi up there. And we're just going to have that dotted in. Okay, we just moved it over a little bit. Okay, I'm like, yes, there is another one over here somewhere. Okay, so if we wanted to have like the whole graph like that, we could. Okay, and that's going to be our graph. Right? So let's go ahead and do this. So we're going to put in some asymptotes here. All right, so we've got, there we go. So we've got a 5 pi over 4, we've got a 7 pi over 4, we've got a 9 pi over 4. Okay. And then here we've got a 3 pi over 4, we're at 1. And then we are at 7 pi over 4 down here at -1. All right. So just following my graph here. Like, yes, I am using some symmetry and the fact that I know what it's supposed to look like before to kind of dot that in. But, you know, if somebody asked me a more complicated question, I'd be glad I had a picture to look at. All right. And there's our graph. Okay. So it's a little bit offset, a little bit over. Check our answer. All right. And we're doing pretty well. All right, let's see what we have here. Okay, we're going to express the distance in miles between the plane and the tower as a function of the angle and standard position from the tower to the plane. Okay. All right. So let's just do a couple of what ifs and see what happens here, okay? All right, so here's my tower. Okay, and it says a plane flying at an altitude of 5 miles travels on a path directly over a radar tower. All right, so okay, here's our airplane. This is going to be 5 miles. Okay, so at our 5 mile, it's directly over, right? When t, our angle t equals 90 degrees, equals pi over 2. Okay, our distance is 5 miles. All right. Now let's deal with some what if things. Okay. Can't believe they didn't give us a tangent one to deal with first. All right. What if t is equal to 0? Our distance is 5 miles, right? No, t is the angle. Sorry, t is the angle. So we're going to say that this is here, that this is pi over 2. Okay. So what if we have a little tower here, like the tower square? Okay, this is 5. And what if, just trying to decide how I want to measure my angle here. So I want to measure this angle. The picture kind of makes it look like we're measuring this one here. All right. So I think this is the one we want. Okay, so why don't we make this t here? We'll make this pi over 4. Okay, so we'll have our angle in standard position. Okay, thank you. Okay, that would be this one. Okay, so angle in standard position. It's here. Okay, we have pi over 4. We know that the height, right, that this is 5. And we have to figure out the hypotenuse here, right? We have to figure out this hypotenuse, because here's our airplane. Right? So I'm just trying to draw a triangle. Okay. So we have to figure out what this value is here. Okay, what is this? What is this hypotenuse? So can you think of an angle with something that relates a hypotenuse and an opposite to an angle? Okay, so I kind of think that's going to be sine. Okay, and my first thought would be, okay, the sine of an angle is equal to the opposite over the hypotenuse. And we're trying to solve for the hypotenuse. Okay. So we have hypotenuse is equal to, right, the opposite side, OPP, divided by the sine of that angle. Okay. Normally we could say something about a cosecant. Okay, so we could say hypotenuse is equal to 5 cosecant theta. Just going to put that off to the side here because we're going to do some more. Okay, because we're trying to find a pattern. Okay, so yeah, we have hypotenuse is equal to 5 over sine of pi over 4. Okay, and since we're trying to do a thing here, I've got my, right, this is 5 cosecant pi over 4, so let's just check out what's happening here. So we have 5 divided by pi, the sine of, am I in radians? I sure am. See, checking it, make sure we're in radians. Okay, sine of pi over 4. Okay, of course it is. Oops. No, that's right. We're good. Okay, so this was 7.071. Okay, I feel like I should have known that. All right, so there we are. All right, same thing is going to be on the other side. So when the angle is 3 pi over 4, right, in standard position. Okay, so when t equals 3 pi, remember t is, they've picked theta. Okay, t is not time, it's the angle that it makes with the tower. Okay, so that's still going to be 5 over sine of 3 pi over 4, which is 5 times cosecant of 3 pi over 4. Okay, so let's keep going with this. Right. Yeah. All right. So let's see here. Yeah. Okay. Let's see about how about if we do pi over 6? So let's draw the picture here. We have our little tower here. We've got our space or plane. It's 5. Okay, we're not going to put it there though, so let's get rid of that. Okay. And again, we're measuring our angle in standard position, so it's from the ground up. Okay, so let's make it pi over 6. Okay, what's that going to do? Okay, and again, we know this is 5, right? Because the altitude is always 5. Okay, and we have to figure out, like, what is this hypotenuse? What is this distance here? Okay, that's what they want to know. So again, we have to think, well, okay, we need sine of theta is equal to the opposite over the hypotenuse. So we're trying to find the hypotenuse. So hypotenuse equals, right, opposite over sine theta, which is opposite equals 5. And then I can just write this out a little bit, right? Cosecant pi over 6. Really what we're going to do is we're going to say 5 over sine of pi over 6, right? Sine of pi over 6, that's a half. So this is going to be 5 divided by 1/2. So this is 5 times 2 is equal to 10. Okay, so when this is pi over 6, this value here is going to be 10. So I think you're sensing kind of a pattern of what's going on here. So could we do something like the distance of time, the distance of the angle okay, is equal to 5 cosecant of my t, okay, where t is met angle from standard position to, elevation of where the plane is. 5 is going to be that. I think every time we do this problem, we're going to be setting up the same thing. So I think we're going to be okay with, this is my function. All right. So I'm going to say this is equal to 5 cosecant of t. All right. And we'll check. Okay. All right. So if d is equal to 5, what is the angle? Where is the plane located at the tower? We did this, right? If d is equal to 5, then our angle is 90 degrees from the tower, right? That's pi over 2. In this case, they wanted 90 degrees, and the plane is directly overhead from the tower. But what about the asymptotes? Cosecant has asymptotes. What if I make the angle is just barely over, like the plane is all the way on the horizon kind of thing, or beyond it. Like if it's just barely peeking over, right? It's a very small, it's very far away. So the angle it makes, right, is, I mean, this is still 5, right? But this angle is really, really tiny. So we can keep going down, go down, go down. So that's where the asymptote comes from. It's like it just peaks barely over the ground. Okay, but it's still 5 miles up. But the way we see it with the angle is just barely over. So that distance is going to go off, right? It's going to get larger and larger and larger until well, the infinity is not really going to happen, but yeah. But there we go. All right. Can the value of the plane be pi? No. Right? It cannot be pi because pi is it's not in the domain of d. Okay. That's where the asymptote is. The asymptotes are not part of the domain. Okay. And if it was, it would be like we would literally be on like a flat Earth for this to happen, for us to see something like this. Okay, and it's just not. It's going to be over the horizon, way over the horizon by the time we see that, even though it's 5 miles up. All right, so there we go. All right, give me a moment. I'm going to go ahead and get myself a drink. Pause. Actually, I'm going to go ahead and cut us out now so we can have one sequence of doing word problems and other weird problems with cosecants and secants. And our next video, I'll take care of the rest of these and we'll do tangents and cotangents. All right. So I'll leave it there and I will see you in the next video. All right. Thank you.